Hi guys, I decided to put together a video about a problem I came across recently. I needed to animate a product in the browser using the scroll bar, as you can see on the screen now. I didn't find a good solution for this problem without lag. One approach is relying on syncing the timeline of a video player to the desired position in order to display the correct frame. Another one is just simply replacing the image source with the correct image frame. The fundamental problem with these solutions is that in both cases, the video or image data has to be uploaded to the GPU in real time. The animation is smoother if all textures are stored in advance and only displayed when needed. Before start coding, let me show you the basic working principle of this. So first we will create the HTML document body, then we will add a header, a footer, and in between a taller div, which I will call trench. In this trench we will have our OpenGL canvas, where the full screen quad will be rendered using the desired texture. For better visuals, I added this yellow rectangle and monitor to represent the current viewport. As sliding down, our sticky canvas will try to remain in the viewport. Stopping right at the end of the trench, we have reached the last frame we want to display. And that's basically it. Now we will need to have a sequence of images. I am using WebP format because of its small size. You can create animation, for instance, using Blender, or just simply take an existing video and extract the frames using FFmpeg. Let's jump right into the coding part. We have this basic HTML with the divs, CSS and some external JavaScript code. app.js has this differ keyword which will make it executed after the document is parsed. The CSS is very minimal. What we're noting is the trench height. It controls how much we have to scroll in order to play all the frames. And the other thing is this sticky canvas, which will try to remain in the viewport. Matrix.js is a very minimal script, essentially just provides an identity matrix. gl.js is doing all the OpenGL related good stuff. It will load the textures and store them in the GPU memory. We will need one buffer for the quad coordinates, which we made out of two triangles. And we need another buffer for the UV coordinates. The vertex shader code isn't complicated. One extra thing I have to mention is this scalar value to keep the aspect ratio of the textures. The fragment shader is just samples the texture based on the UV coordinates. app.js contains some utility functions and the main logic. One useful thing is this map function, which will project one range to another. Calc percentage function will calculate our progress based on the scrollbar position. Actually not directly from the scrollbar position, but instead it will use the distance between the top of the viewport and the top of the trench div. Draw scene is the workhorse of this application. One important thing it does is that it calls the previously mentioned functions to obtain the current frame number. It binds the appropriate texture, sets up all the required buffers for the shaders, and last but not least, it calculates the scalar values based on the aspect ratio. Finally, it will draw the textured quad onto the screen. At the end of the file, here is how my JS should be configured. It requires the number of textures, the path to the image file sequence, and the file extension. One final thought, probably this code can be rewritten in WebGPU, so it could be even more efficient. You can find all the files for this project in my GitHub, link in the video description. I hope you found this video helpful. Thanks for watching and goodbye.